Have you ever wondered how companies create secure connections over the public internet? Or how your data stays private when you use a VPN? The answer often lies in a powerful framework called IPsec. But what exactly is it, and how does it work? The Standard Internet Protocol, or IP, was never designed with security in mind. It's great at getting data from point A to point B, but it does nothing to protect that data along the way. And that's where IPsec comes in. IPsec, which stands for Internet Protocol Security, is a suite of protocols that secures IP communications at the network layer and provides four crucial security features. Confidentiality. It encrypts your data so only the intended recipient can read it. Integrity. It ensures your data hasn't been tampered with in transit. Authentication. It verifies that you are communicating with who you think you are. Anti-replay. It prevents attackers from capturing your data and resending it later. It sounds complex, and it can be, but we'll break IPsec into simple, understandable parts, covering how secure tunnels are built and how your data is actually protected. So let's get started. IKE in two phases. Before IPsec can protect any data, the two devices, called peers, need to establish a secure connection using a protocol called IKE, the Internet Key Exchange, and this process happens in two distinct phases. First, we have IKE Phase 1, whose main goal is to create a secure, authenticated channel between the two peers, a fortified management tunnel called the ISAKMP tunnel. Inside Phase 1, the peers negotiate a set of security rules called a Security Association MSA, agreeing on several items. Hashing algorithms like MD5 or SHA for integrity. Authentication methods, usually a pre-shared key or digital certificates. A Diffie-Hellman group, which determines the strength of the keys they will create. Encryption algorithms like DES, 3DEs, or AES to keep the conversation private. Once the secure Phase 1 tunnel is up, we move to IKE Phase 2 inside the protection of the first tunnel to negotiate the security parameters for the actual tunnel that your data will flow through, often called the IPsec tunnel. So, to recap, Phase 1 builds a secure management tunnel, and Phase 2 uses that secure tunnel to build the data tunnel. Phase 1 modes. IKEv 1 offers two ways to complete Phase 1. Main mode and aggressive mode. Main mode is the more secure and more common method, using a total of 6 messages to complete the negotiation. The first 2 messages are for negotiating the security policies. The next 2 are for exchanging Diffie-Hellman key material to create a shared secret key. And the final 2 messages used to authenticate and identify each peer are encrypted to keep identities private. Aggressive mode, as the name implies, is faster and accomplishes the same goal in only 3 messages by packing more information into each one. But that speed comes at a cost. The big security risk with aggressive mode is that identification information is sent in clear text before the secure channel is established, exposing peer identities and making the connection vulnerable to certain attacks. So main mode is almost always preferred. Once Phase 1 is complete, we have our secure ISAKMP tunnel, and we're ready for Phase 2. Phase 2, Quick Mode. Phase 2 is much simpler and uses a single mode called Quick Mode. And remember, this negotiation is already protected by the Phase 1 tunnel. In Quick Mode, the peers negotiate a separate security association specifically for the user data tunnel and agree on a few key things. Which IPsec protocol to use? AH or ESP. The encapsulation mode, tunnel or transport. The encryption and authentication algorithms to protect the data. The lifetime for the tunnel, specifying how long keys are valid before refresh. Once Quick Mode is complete, both the Phase 1 and Phase 2 tunnels are up. And now we're finally ready to protect some data using AH or ESP. AH versus ESP. IKE's job is to build the tunnels, but the actual work of protecting the data is done by one of 2 protocols, or ESP. First, the Authentication Header, provides excellent integrity and authentication by creating a hash that covers almost the entire IP packet, including the IP header. So if even one bit changes in transit, the hash won't match and the packet is dropped. And also provides anti-replay protection. But has one major limitation. It provides no encryption, so your data is protected from modification but not from being seen. Also doesn't work with NAT because it hashes the source and destination IP addresses, and a NAT device changing those addresses causes the hash to fail, making unusable in most modern networks. ESP, the Encapsulating Security Payload, is the more popular choice today because it provides everything does plus confidentiality through encryption by encrypting the payload of the IP packet so your data is unreadable to anyone who intercepts it. ESP also provides its own integrity and authentication but doesn't cover the outer IP header in the same way. And since it doesn't hash the IP addresses, it works fine with NAT and is far more flexible. Transport versus tunnel mode. Both and ESP can operate in two different modes, transport mode and tunnel mode. Transport mode is designed to secure traffic between two specific endpoints, like a connection from your PC to a server, inserting the IPsec header between the original IP header and the payload so the payload is protected while the original IP header remains intact. Tunnel mode is the basis for most VPNs, especially site-to-site VPNs, encapsulating and encrypting the entire original IP packet and adding a completely new outer IP header so private internal addressing can be carried across the public internet securely with original source and destination hidden. So, the most common IPsec configuration you'll see is ESP in tunnel mode for full encryption and authentication while hiding internal network structure. Recap. So let's quickly recap what we've learned. IPsec secures IP traffic, providing confidentiality, integrity, authentication, and anti-replay protection. IKE builds secure tunnels in two phases. Phase 1 creates a secure management tunnel using main mode or aggressive mode, and Phase 2, quick mode, creates the data tunnel. Data protection uses or ESP. Offers integrity but no encryption and is incompatible with NAT, while ESP provides encryption and integrity and is the most common choice. Transport mode protects the payload between hosts, while tunnel mode encapsulates the entire original packet with a new IP header and is ideal for VPNs. IPsec is a complex topic, but breaking it down into IKE phases, versus ESP, and transport versus tunnel modes makes it much easier to understand. If this explanation helped, be sure to like and subscribe for more networking and security content, and drop any questions in the comments below. Thanks for watching.